Hello and welcome to the Sequire Spotlight. I'm Jonathan Miller, Vice President of Business Development for Schrax. I am joined today by Ian Jenks, Chairman of the Board and CEO for SmartKem, ticker symbol SMTK on the OTC markets. Now, Ian Tudor Jenks is a British business person who founded Ian Jenks Limited and who has been the head of 13 different companies. He occupies the position of Chairman of Zeta Networks Limited, Chairman and Chief Executive Officer of SmartKem Inc., Chief Executive Officer and Director at SmartKem Limited, as a subsidiary of SmartKem, and Chief Executive Officer at Ian Jenks Limited. Mr. Jenks has also been on the board of Econic Technologies Limited and Brady Trading Limited, an associate member at the Institution of Mechanical Engineers. In the past, he was the executive chairman for Intune Networks Limited, chairman for TechStep ASA, non-executive chairman for Aldwick in 2011 Limited, and non-executive chairman of Ryovan Limited and president for Uniphase Inc. Ian, you have quite the extensive background and a lot of experience. Thank you for joining us here today.
It's my pleasure. I'm not sure about the experience, but I think it just means I'm old.
Well, it's great to have someone as qualified at the helm, steering the company. And from what we understand, SmartKem is seeking to reshape the world of electronics with a revolutionary semiconductor platform that enables a new generation of displays, sensors, and logic. And you have patented what's called the TrueFlex inks, which is a solution deposited at low temperatures on a low-cost substrate to make organic thin film transistors. Would you like to elaborate a little bit more on this?
Sure. So we make, as you rightly said, polymer liquids. Those liquids are used to make a new type of transistor, an organic thin film transistor. And those transistors are used to drive, in particular, a new generation of what are called micro LED displays. Today, the world is populated by liquid crystal displays, the sort of thing you see on your monitor, and they do a great job. And more recently, OLED displays. Most people would have seen those if they'd gone into Best Buy and looked for large-scale televisions with the really bright poppy colors. The trouble with both of those types of displays, when you start to use them in the real world, and especially if you start to use them in AR and VR applications, but also in your watch and your mobile phone and your laptop, is that all of us have tried to read our phone in sunlight. They're just not bright enough. And all of us would wish for a longer battery life. And those things are delivered by what's called a light emitting diode, an LED. It's the thing that's changed in all of our households as we've gone from these incandescent light bulbs to LED bulbs. And we do that because they consume a lot less power and they're plenty bright enough. So the world is moving in the direction of LED displays. So lots of direct light emitting displays. And they're great things, super bright, low power consumption, and just what we all want. There's a problem, however. To make them, you take a large piece of glass and you cover it with lots of very small micro LEDs. And when I say lots of, I'm talking 24 million little LEDs. And then you take another sheet of glass with 24 million transistors, and you put the two of them together and you squeeze them at just the right pressure, and then you have to weld them all together. And that's a really, really difficult thing to do. And it's expensive, it doesn't yield very well. And so even if you get higher yields, 99.9% yield, you still have thousands of pixels out of those 24 million, which don't work or are too bright. And so what we're bringing to solve this problem is it's not too difficult, believe it or not, to put 24 million little micro LEDs on a sheet of glass. And so what we do is we simply pour our liquids on the top, spread them out, pattern them with conventional photolithography processes, and we make the transistors directly on top of the micro LED. So we eliminate this problem of how do you align 24 million with 24 million completely. No welding, no assembly, one sheet of glass, and that's your new generation of display. And we think we can reduce the cost of the LEDs by about 80%. We think we can reduce the cost of the transistors by about 80%. And you take something that today costs tens of thousands of dollars, and for the first time, you bring it into the arena of the mass market. So that's what we do.
It's very impressive, and I can attest to the brightness and the quality of these. We have a OLED in our bedroom, and wasn't aware of the complexities behind the manufacturing of these. And from what I understand, most of the research, R&D, and development is done in Manchester at your headquarters there. Would you like to tell us a little bit more about the facility where these are manufactured?
Sure. So we manufacture the inks, and other people manufacture displays. So in Manchester, it's a really interesting place. It has a long and illustrious history of the development of polymers, going all the way back to the very first things like terylene and Dacron that were made and changed the world of clothing. So it has a unique infrastructure of a center of excellence of polymer chemists. And it was some of those polymer chemists that came up with this new way of using polymers to make transistors. So there we have our chemistry team. About 2 hours north of a place called Darlington, there's a Center for Process Innovation, where we actually have a prototyping line that allows us to patent these transistors and develop the processes by which you make the transistors on top of sheets of LEDs. And when we take those liquids, which we actually develop in Manchester but manufacture in the United States, and we take the processes and the technology, and we license the processes as we sell the inks. And most of our customers, and we are a very early stage company, so I don't want you to think we're in mass production, technology at prototype stage. And most of our customers are actually in the Far East, mostly in Taiwan, where there is a huge manufacturing infrastructure for the manufacture of LCD displays. And today we have 3 customers who are trialing our materials in individual layers. And we have 2 JDAs with customers in Taiwan who are actually starting to build prototype displays. Actually, one is using our materials to help them build a better OLED display, and the other is actually making micro LEDs.
Very impressive. And there's obviously a lot of applications in commercial and consumer technology here. Are you able to speak to any of maybe the big consumer brands that you would be approaching with this technology?
I think it would be remiss of me to name drop consumer brands. As you'll be very aware, they really don't like it. But plenty of them have made announcements about the lack of availability of a display that is bright enough, at a low enough cost, with a long enough battery lifetime. And it's those characteristics, or the lack of them in the world today, that actually, I believe, is inhibiting the deployment of this enhanced world that we're all really looking forward to, whether it's through AR glasses, VR headsets, or actually, much more importantly, in the displays that surround us all the time. And so the prospect of having a display that's bright enough that in daylight could be in the window of a shop, actually stuck on the glass, that actually entices you in, that gives you the personalized information that you want, a display that you can read in daylight in your car. Those sorts of applications are what we are hoping to enable.
Very, very nice. And now we barely grazed on your background and in your experience. Would you like to tell our viewers a little bit more about how you came to this position of being chairman and CEO of the company?
Sure. Well, if you go back far enough, which is quite a long way, I did my first startup in a laser business in the United Kingdom. making a laser for very exotically named Fourier transform mass spectroscopy, which was a product that we were making and selling to PerkinElmer. I sold that business to Uniphase on the West Coast, moved over there as president of Uniphase and grew that to be one of the world's large telecommunications components suppliers. Moved on, took Uplink Communications public on NASDAQ, did a decade as a partner in a West Coast venture capital fund. And then I relocated back to the United Kingdom, where I sat on, as you listed, a number of different boards and chaired a few. I was asked about 5 years ago to join the board at SmartKem. I really liked what they were doing. I took over as chairman 2 years later, and a year after that, I took over as the CEO and took them public on the OTC QB market 2 years ago. And like all companies of our size, as we become more successful, I'm hoping to repeat the pattern and move them up to one of the major markets sooner rather than later.
It sounds like you've had a lot of exciting journeys in your careers. Over the last 3 years, there's obviously been a lot going on that's impacted global supply chains. How did the last 3 years affect the business, and how were you able to overcome some of these obstacles that your industry may have faced?
Really good question. It has been, I think, the most brutal last 2 years of my career. Being locked down, I personally was locked down in my home, actually not able to move more than a few hundred yards from my home for nearly 6 months. It was a terrible experience. We were very fortunate that one of the great things about working in the chemistry industry and in the semiconductor industry is, of course, you're working in very clean rooms. And we actually increased the filtration on our clean rooms. They became some of the safest places that you could exist during the COVID pandemic. Sure. So we were able to keep working all the way through, and we worked in the office, and most of our employees were delighted actually to come into work because they felt really safe in that environment. Where it did impact us hugely, of course, was our customers are all in the Far East. And we were unable to travel. Many parts of the Far East were locked down. Many of our customers actually shut their business for nearly 12 months. So we were able to continue to develop, and actually it gave us the bandwidth to come up with some of these ideas that I've been talking about in terms of micro displays. So I would say it was a mixed blessing. What I would say in the last 6 months, we've been able to traveling more frequently to the Far East. I actually spent a week there in November, where I was locked down in a hotel room, which was a unique experience for 7 days. But our customers in the Far East have been extremely grateful for us to make that effort, and very receptive to new ideas and to us as in particular. So a mixed blessing, difficult, but we've managed to get through it.
That's excellent. I know these challenges have presented opportunities for us to think outside of the box and come together and make things work. And I understand, as you mentioned, you had some ideas that were bubbled up during this time. And I read an article recently that you're releasing the first monolithic LED display. Is that correct? Can you tell us a little bit more about the new products on the horizon?
And that's the antecedent of what I've just been talking about at a larger scale. So this is how we thought of the idea. So, small displays and all of these LEDs are actually made on wafers. So you get a bunch of wafers, and it occurred to a little group of us as we were having a discussion. Well, why don't people just put the transistors directly on top of these things? And the answer comes that existing types of transistors that are made at scale are made at very high temperatures. And if you try and make them on top of a wafer of LEDs at those temperatures, the LEDs get destroyed. But we, as you said earlier, we process at 80 degrees. So we said, well, why can't we, with our solution coding, do them at 80 degrees? And we asked Steve Denbars, he and my old friend Suji Nakamura. So they are at UC Santa Barbara. Suji got the Nobel Prize for inventing the blue LED. So he's someone who should know. And asked the question. They said, well, no one's tried it. Give it a try. So we did. And it worked. And so we've made the first monolithic single color display that's in using organic thin film transistors, solution coated on top. And we've taken that idea that we did about 6 months ago and developed and actually released to the market in the early part of, well, the last quarter of last year for small displays. And we've taken that and said, well, could we expand that concept of a monolithic structure to micro LEDs on a big scale? And so that's what we're doing now. But we as a company, of course, if we're selling liquids and inks, then we want to sell large amounts of ink. So we want large volume, large areas to coat. It's like selling paint and painting the wall. You want to paint lots of walls. So this for us represents a major breakthrough in being able to address a market that we think is, just for our inks, is somewhere between $2 and $4 billion over the next over the next few years.
That sounds exciting. And when we say monolithic, are we thinking of displays like in sports stadiums or billboards? Where would we typically see these types?
The monolithic refers to taking a layer and then just continually coating on top of it. So you have a completely solid structure. If we look at where our customers are interested in taking it, it's everything from really small displays up to panels. And so if you've ever looked at these huge displays that you see today, they're actually made up of little panels about this big. Yep. And they all bolt together. And if you've ever leant your hand against one, you'll find it's really quite hot. They consume a lot of electricity. So certainly one of our partners at the moment is looking at this technology to take it into advertising type, hoarding type sizes. But in principle, we can make things out of large sheets. We've already made sheets of our material that are about a square yard. So we can make big panels.
So we could assume that this also sort of plays into ESG by having a lower environmental footprint or impact by consuming less electricity and being able to do the same thing, basically.
And not just when they're being used by consumers, but also in the manufacturing. The fact that we're a low temperature process, heating things up to several hundred degrees requires a huge amount of electricity. And we eliminate that part of the program of the process. And then today, existing types of transistors are etched using fluorine compounds, which are environmentally very unfriendly. And we eliminate the need to do that because we're a polymer and we can etch it using oxygen plasmas.
That's great. And obviously it's 2023, technology is accelerating at an exponential rate. How are you able to track some of the trends in your industry and keep up?
Well, fortunately, we have a number of trade organizations which are great talking shops. So the biggest globally is the Society for Information and Display. They hold lots of symposiums and a really big show in the States in May. And then in Europe, there's an organization called TechBlick, which is a little bit more technical. But I think we all compete, but we all collaborate as well, because none of us have the complete answer here. We may have the transistors, somebody else has the LEDs, somebody else may have some of the electronics. And we are all both competitors and partners in the development of what we all think are life-changing displays.
Fantastic. And what do you expect the market to look like in the next 5 years with the adoption of these products?
So adopting products, I mean, the display markets, I don't know, about $180 billion. And it's slow to evolve. Today, it's dominated by LCD with about 75% of the market. A quarter of it is OLED. There's this big battle going on between those as to quality and price. We think that the micro LED televisions are already out there. Micro LED televisions are probably things that are going to start appearing the end of 2024, early 2025. In the meantime, though, there's lots of things that people can do with our materials for existing displays whilst they bring up production lines and test the new types of display. Because the last thing that you want is, I don't know if you remember plasma TVs. We all bought plasma TVs, and 2 years later we found out that the image, ghosted on the plasma TVs, where you had a company logo or something. So and they disappeared off the market. So a lot of testing to be done, a lot of production optimization to be done, but in the meantime, still a decent prospect of ramping revenues.
How big of a part do you see nanotechnology playing in your industry?
I'm not sure where you define nanotechnology these days. It's a lot smaller than it used to be. I don't think that we are actually at the scale of nanotechnology. The smallest things that we deal with are being measured in microns. So,
Pretty small.
a thousandth of an inch, but that's not small. So, the smallest things that are measured in semiconductor processors are measured at 5 nanometers. That's 5 billionths of an inch. So, I mean, they are very small. So nanoscale, I think, is down that end. At our end, we're talking about LEDs, which today that you see in these big displays are about a 20th of an inch square. We're taking those down to maybe 5 to 10 microns square. And then the feature size of our transistors is about half a micron. So small, large by semiconductor standards, but still pretty small.
Yeah, absolutely. And for our investors out there, where can we find out more about the company?
So we're a public company. All of our information, all of our publications are readily available. www.smartkem.com, and that's SMARTKEM.com.
And again, it's SMTK on the OTC exchange. And do you have any closing remarks, anything that we should keep an eye out for?
So if I look forward, a measure of our progress at this stage of our development is our ability to engage with customers. That's customers who trial our products and look for announcements about that. But more importantly, look for announcements about joint development agreements, especially with manufacturers of micro LEDs.
Thank you so much, Ian. It sounds like you have a lot of exciting work in the pipe, and we look forward to following along and tracking your story and your successes. And thank you so much for being here today and sharing your story with our viewers.
It's been an absolute delight as always.
Thank you.
Thank you.